Greetings, Doctor. Our group is comprised of Derrick, Jiawen, and myself, VEYCENT. And for our group assignment, we have picked the circuit shown in the next slide, as in the circuit is in some kind of nested parallel circuits. From the circuit, it can be seen that R4 and R5 are parallel with each other. Therefore, I3 is the total current that is divided into these resistors. Let's let R3 be the total resistance of R4 and R5, and we can get it as 2/3 ohms. Similarly, R2 is parallel with R3. Then let's let RE be the total resistance of these resistors, which is 4/7 ohms. Finally, R1 is now in series with RE, and therefore we can get the total resistance by using the series resistance formula and get it total resistance as 25/7. Then from the R total resistance, we can get the total current by using Ohm's law. And since I1 is equivalent to IT, we can conclude that the current flowing through is 56 amperes. Saving the data from the previous slide in the top corner for reference. And then now we have to find the current that is flowing through I2 and I3. And according to Kirchhoff's current law, the net flow of current into one node is the same as the current out of the node, and for this instance is this node over here. Therefore, I1 is equals to I2 plus I3. To find the resistor, we can apply either voltage divider rule or in series or current divider rule in parallel. For this instance, let's use the voltage divider rule for R1 and RE. Using the formula for voltage divider rule, VE is equivalent to the V source times RE over the R total, which is R1 plus RE. And we plug in the numbers, we can get that the voltage through RE is 32 volts. And once again, using Ohm's law, we can conclude that I2 is 8 ampere and I3 is 48 ampere. And to double check, we can use the Kirchhoff's current law rule and still get the same answer. Next, we have to find I4 and I5. This time we're going to apply the current divider rule, and using the current divider rule formula, I4 is equivalent to I source times the opposite resistance over the total resistance. So in this instance, it's equivalent to 48 times 2, which is the opposite of this R4, plus the total. Then we can get 32 ampere. Similarly, for I5, we still use the opposite resistor and can get I5 at 16 ampere. You can also double check using Kirchhoff's current law, and therefore we finally can conclude that we have successfully gotten the final resistance for all the required all the required currents.